Thank you, Steph. I am excited to talk to you about. Look, UCC has become everything. UCC is not just UCC meeting spaces anymore. It's classrooms. It's going to be in multi-purpose spaces. We're going to see technology like what you're about to see revolutionize meeting spaces that weren't even called meeting rooms before, where we're using spaces in not just hallways that would normally have been called huddle spaces, but also in big spaces where, maybe it's a cafeteria at some point in time and it's also being used for meetings, or maybe it's the lobby of a building, or maybe it's a multi-purpose facility. And the key is going to be accomplishing meeting equity, making a good experience for everybody. And that a big part of that experience is audio. Look, you can always have a meeting without video, but you can never have a meeting without good audio, which is why I want to introduce you to Mark Donovan. Mark Donovan, many of you probably already know Mark. He's been at Audio-Technica for forever. He's the applications engineering manager for the pro market. Mark, how are you doing?
Doing very well today. Thank you, Gary.
It's great to see you again. You're the audio guru in the UC world for our industry, and I appreciate you being here today. I'm excited about this session. At the end of this, we're going to do a demo of what we're going to talk about today. But first, we ought to talk about. I want to first start with the fact that Audio-Technica, instead of reinventing the wheel, as you said, Mark, is using Sony's VISCA standard, which is the video system control architecture, to do some really cool things to amp up your product line, specifically the AT&D 1061 beamforming ceiling microphone. Can you start with that, if you don't mind, Mark?
Yeah, and actually, it's interesting to hit on what you said earlier. I find it exciting because we're finding end users are just doing things with these products, and they're doing applications that we never really expected, that we never really thought about when we were planning out these products. And it's really cool to see that. And of course, with newer technology like, technology-based pieces like the AT&T 1061, we're able to adapt much more quickly to that. And so, when we started seeing people, using these more flexible spaces, we started seeing people wanted to get that meeting equity even into smaller spaces or spaces that aren't that complicated. We kind of answered the call to kind of reach out and say, okay, let's get things talking together between our microphone and other VISCA-enabled video products, PTZ cameras, and just try to make this simpler for everybody.
So the idea here is that because they're using VISCA and they've got compatible cameras, you can do a better job pinpointing where the person is who is speaking at any moment in time as they move around the room, which gives you a better experience remotely, but also a better experience for the recording. A lot of these meetings are being recorded and watched back later, not just being done live, especially as we see in training environments. So talk about sort of how that works.
Well, I mean, when you look at the beamforming microphone, AT&T 1061, really at the core of it is its location ability, its ability to tell where a talker is. That's how that beam follows around a person and keeps that audio nice and clear, is that it knows exactly where my voice is coming from. And it's really just a logical next step to take that data and provide it somewhere else. So as we did from the beginning, we provided that data out on the network, so that other control systems and things like that could capture that data and then translate that to talk directly to a camera. And what we've done, though, is we've kind of jumped that step right there. We've put that, interpreter inside of our microphone so that now we can speak directly to a pan tilt zoom camera and say, here's the location data. Here's where I am. Here's where this talker is. Change your position based on that. It's just adapting to those needs.
And are you doing all that IP? And it's all connected. Every piece of equipment is connected through the network, including your mic. And what's the box that's making it talk together, or is there any kind of control that you're connecting it to?
That's the beautiful thing about it, is because there isn't any extra hardware. We're not adding some translator, some piece of equipment in between here and there. This is IP communication directly from the microphone directly to the camera. Provided they're on the same network, you go into the microphone setup and say, hey, here's the IP address of the camera, and those two are going to talk. You enable the VISCA-over-IP on the camera, and because it's something that Sony developed a long time ago, this is nothing new to the PTZ world, right? So most of these cameras that are out there, they understand VISCA. It's all baked into it. So it's really quite simple. And like I said, leveraging technology that's already there.
So you have a product. Part of this, I think, is the digital microphone manager software suite.
Right.
Talk about that for a second. And is that something that an average person can use? Does it require some sort of training or certification from Audio-Technica, or what's the process there?
It's a very intuitive software. It's pretty simple when you light it off. Everything is all very clear, as to what is what. I think that most people can pick it up just simply by poking through here. Most of us in our industry kind of do that first. We're always to kind of poke at software and hardware before we read manuals. So what I found is that most people have no problem with that whatsoever. Now, that being said, we've got a lot of videos on it. On our website, we've got a great user's manual for that, as well as our team, the applications engineering team, which is always happy to get on the phone and get on a call like this, actually get on a call and walk people through it. So we don't have a formal training thing because, quite frankly, it's not that complicated, but we're happy to help everybody out. So,
okay, so let's talk about what if I have multiple cameras in a room? Like, what if I'm doing one of these new systems where everyone's talking about, doing this AI-based camera switching, right? We're using VISCA camera, but we're doing this AI-based camera switching. How do you handle that?
Well, generally speaking, when you're talking about using VISCA-over-IP, you're talking about a one-to-one piece. You're talking about a single microphone talking to a single camera.
Okay.
However, that data that's going out, that location data, can also be used by other devices. I mean, there's QSys, for example.
Yeah.
Working with Crestron, working with all these other control and DSP companies that can capture that data and then use that within their own AI software or whatever to start looking at, okay, let's do multiple camera angles, let's do masking shots and do all this kind of thing. So we provide all the data that is necessary to do just a simple, here's a small room, one camera, we're going to do a left shot, a right shot, or you can do it to provide that data so we can do a back camera and two front cameras or whatever. So, like I said, the information, which there's a significant amount of it that you can pull off of this microphone, is there for anybody to use.
And then also you've added voice lift, which
yes.
Yeah. And talk, I mean, that's something I think that everyone has. I think a lot of people think in small spaces, you don't need voice lift, but then they don't realize the value of voice lift. Talk about that, because I'm sure that was well received at ISE.
It was. And I think the thing that we have to understand about voice lift is really what the point of voice lift is. I think some people think of voice lift, they think of sound reinforcement, and that's not really what we're talking about. We're talking about focused, clarification of voice for intelligibility to specific locations. The perfect
Are you doing that? Are they wearing anything? Are you just
are
you painting out an area in the room and saying this is the sweet spot to do voice lift?
Right. So let's give you an example. Let's say an example that needs voice lift would be a classroom, right? You got not necessarily a huge classroom, but a larger classroom where you got an instructor up front who's maybe it doesn't have that old school projection voice and needs to get some audio to the back of the classroom so that they can understand it clearly. I mean, we don't require somebody to wear anything because remember, we talked about that location information for the cameras.
Yeah.
That location information is allowing a beam to track this instructor as the instructor moves around. Now
you don't even have to in your software preset an area in the digital microphone manager. It's doing it in real time with where the camera notices that person. The camera and the audio notices the person is.
Exactly. And the beautiful thing is you can manage all these things separately. So you can manage the audio that's going to the far side, the location information that's feeding your camera, and the audio that's going to voice lift, all independently. So you don't have to sacrifice one or just have to, do all these weird little balance things to make it all work out. You can set everything else up by itself and not sacrifice any of your audio quality or your video accuracy. And all
what kind of delay is there? If I'm in the back of the classroom and you're using voice lift and you're helping augment that audio, what is it, a noticeable delay? Is it just
it's going to depend. It's going to depend on how much processing you bring into play. So in a smaller room, you're going to have to use more processing to get
Yeah.
more gain before feedback. Your typical,
Yeah.
potential acoustic versus needed acoustic gain problem. So the more processing you kick in, the longer that's going to delay. This is just the nature of adding more
Yeah.
DSP blocks.
Yeah.
In a larger space where you don't need as much processing because you don't have that big of a problem, that latency is going to be much lower. In fact, I think that the latency that the voice going over air, that sheer distance, is going to be equal to, or maybe even more than the latency that the processor's doing.
Yeah, that's interesting. I hadn't thought about it that way, but you're absolutely right. Of course, all of this is at audiotechnica.com.
Yes.
We've put up a link below on, well, actually, lots of different ways to find this. We go to the audiotechnica.com, audio-technica.com website, audio-technica.com, by the way. Don't forget the dash. Although I suspect if you do it wrong, it'll pop up anyway in Google. But they actually have a really good blog on how they added VISCA to improve meeting equity in these spaces. So, Mark, you're going to do a quick demo so that people see how this actually works. So let's roll this video that you shot. That sort of it's real quick. It's a minute or two. Just watch this really quick so you get an idea how this actually operates, and then we'll come back and ask you one last question.
Perfect. So we'll do a quick demonstration of the VISCA-over-IP for the AT&T 1061. You can see on the software here, it's a top-down shot. You can see this little gray dot, and that's the location information. And so that's where the microphone thinks the voice is coming from. And in this context, it's important because it's looking at what group it is in. So you've got all these color boxes up here, which are different groups, and you can have 15 different groups. And each group can be assigned to a different camera preset. So in this particular case, I'm in the yellow box in group number 4, which is assigned to preset number 4 for the camera, which is a zoom-in shot on the head of the table. The scenario being, okay, here's a presiding officer who's giving a board report. But what if somebody needs to have input that's on the sides of this table? How is that handled using VISCA-over-IP? So now in this position, I'm actually triggering a different group. My voice is coming from group number 1, which is triggering a camera preset that's zoomed out slightly. And in the end position, at the end of the table, I'm triggering group number 3, which actually triggers a preset that pans over a little bit to make sure that I maintain in frame. And as the different people talk in these different positions throughout the room, this microphone is able to seamlessly change those presets to make sure that you can maintain that meeting equity as much as possible. Now, mind you, this is also done in a very simple manner. It's not any hardware that's required in between the microphone and the camera. It's not any software that has to be running. This is a direct communication. Our microphone speaks the language of these PTZ cameras, this VISCA-over-IP. So you're able to do this quite simply without a lot of additional costs. And so that's just a really quick idea of what you can do with the simple VISCA-over-IP communication between the AT&T 1061 beamforming array and a PTZ camera.
All right. Thanks, Mark. That was great. Is this available now? When is this, when are you integrating this? And if they already purchased your microphones, can they add it as a software upgrade, or how does that work?
So 2 things. The upgrade, it's a simple firmware upgrade. And it's backwards compatible to any product purchased from day 1 when this came off the line.
Okay.
So you can add all this functionality with a simple firmware upgrade. There's also an upgraded version of the software, but none of this costs money. It's all available on the website. And it was actually released on the 28th of January, right before ISE. And like you said, it kind of made a big splash there at ISE. But we just want to make sure that everybody's aware that it's out there. And we're starting to see a lot more people showing interest in these. We're getting a lot more camera manufacturers talking to us. So, I'm really excited about where this is headed.
Yeah, I mean, that was a great demo, and I really appreciate you coming on. So don't forget, VISCA compatibility and voice lift technology have been added to the AT&T 1061 beamforming ceiling mic array. And you can get more information on that at audio-technica.com, or look below on this page if you're on our launch platform right now. Mark, thank you very much for doing this demo, and thanks for answering all my questions.
All right, thanks. I appreciate everything.
Yeah, I appreciate it. And I'm giving it back to you, Steph, to take it from here. Thanks for watching, everyone.